Welcome to your next lecture in the series on gas laws. For this lecture, you are going to need a pen or pencil and paper, and feel free to pause this as necessary for any concept or application questions that you may have. Hopefully, we will answer those before the end of this lecture. If not, please make sure that you address those with your instructor before we go on to the next in the series. You are also going to need your calculator, so make sure that you have that. And if you haven't written a list of it yet, you do need a list of your standards. Remember that the temperature standard, I'm just going to put temperature standard, and these are just all standards, is 0 degrees Celsius, because the standard temperature is the temperature at which water freezes, which is the same as 273 K. Please note once again that Celsius has a degree sign, whereas Kelvin does not, so that's going to be important for you. Okay. Also remember the chant, shall we say, that if you have C, you add 273. If you have K, you take it away. So to add 273 to Celsius is going to give you Kelvin. To subtract 273 from the temperature is going to give you degrees Celsius. And you subtract that 273 from whatever the Kelvin temperature is. Also, there are the standards for pressure. So at standard temperature and pressure, pressure is 1 atmosphere. It is also 101.3 kilopascals. It is also 760 torr, which is the same as 760 millimeters of mercury. And that is the same as 14.7 psi, or pounds per square inch. So if you haven't written that down, or you don't have that written somewhere, please write that down now so that you'll have it. Okay? All right, if you're ready, go ahead and continue to play, or pause until you get all your things together, your paper, your pencil, and your calculator. All right? Okay, today we're going to be looking at Boyle's law. Boyle's law looks at the condition of gas when it is under a pressure and a volume, but the temperature remains constant. So first thing we need to know is that pressure and volume in the formula for Boyle's is equal to P1V1, and that's the same as the P2V2. So here you're looking at two conditions. In condition 1, whatever that condition is, and I'm going to highlight that with a thing. In condition 1, you have the gas under a particular pressure and a particular volume. And then you may make a change to the pressure or that volume. When you make a change to that pressure or that volume, you now have a condition 2. So if I have a condition 1 with a pressure and volume, and I make a change to the pressure, then I would take and multiply that first condition of pressure and volume divided by the change in that pressure, which then would give me what the volume had to be. If I have a condition and I make a change to the volume, then I would multiply that condition of pressure and volume and divide it by the change in volume to figure out what the new pressure is going to be. Either way, make sure you understand that the value of condition 1 is equal to the value of condition 2. So I may make a change in the pressure, but the multiple of that pressure and the new pressure and the new volume is got to be equal to the same value as the original condition and pressure multiplied together. So you're only going to multiply and divide when you have Boyle's law. Multiply your condition of pressure and volume together, and then you're going to divide it by either the change in your pressure or the change in your volume. Write that down somewhere. Make sure that you know that, and make sure that you know that this is Boyle's law. Make sure that you know that this is the formula for Boyle's law. You need to know the formula by heart, and you need to know which formula it happens to be. Okay? All right, so if pressure and times volume is equal to pressure times volume, then how is pressure related to volume in Boyle's law? Well, if pressure times volume is equal to pressure times volume, that means that pressure, oops, let me clean that up a bit. There we go. That means that pressure and volume are inversely proportional to each other. Inversely proportional to each other. The big word is inversely. That means that if my pressure increases, then my volume is going to decrease. If my pressure increases, then my volume will decrease. Well, what does that mean? Well, if my pressure increases by a factor of 4, then my volume is going to decrease by a factor of 4. Right? So the pressure and volume of Boyle's law, if I increase pressure, I decrease volume. If I increase volume, I decrease pressure, I increase volume in any condition. And there's your formula. Okay? Again, make sure you know your formula. Make sure you know who it belongs to. So if you have your calculator, you've got your pencil, you got your paper or your pen and paper ready, let's go ahead and get ourselves started. I am going to go and set these up for you slowly so that I give you every stage of it. If you have questions, please make sure you pause the video, write the questions down, and hopefully we'll answer those questions in the video. If not, please make sure that you address it with your instructor. Okay? All right. When we look at any of these laws, actually, we will be giving you 3 of the 4 variables when it comes to Boyle's law. And you will have to find the 4th. So 3 of those 4 variables, we are either going to give them to you by just giving them to you, or we're going to have a way where you can find 3 of the 4 variables. Either way, the 4th variable, you're going to have to calculate yourself and find that yourself. All right? All right, let's look at the first problem. In this problem, we are given 250 milliliters of gas at 720 kilopascals. We need to find the volume at 750 kilopascals. When you're doing Boyle's law, or any of the laws, if I give you the unit of volume, you give me the same unit of volume back. If I give you the unit of pressure, you give me the same unit of pressure back. In the case of this, we have our condition 1, which is a volume 1, at 250 milliliters. We have our pressure 1 at 720 kilopascals. The next condition is the volume that we do not know, but we do know our change in pressure. So, using Boyle's law, it is a simple plug and chug. P1 goes where P1 goes, V1 goes where V1 goes, P2 goes where P2 goes, and V2 is, of course, what we're trying to find. So, to set this up, then, we take all the information, plug them into the formula the way they're supposed to be. Again, here is your P1 pressure. This is your V1 volume. This is your P2 pressure. And we need to solve for V2. Well, how do we solve for the unknown? That means we have to get rid of this P2. So how would we do that, of course? Easy. Algebraically, we're going to divide both sides by 750 kilopascals. They cancel out on this side, leaving just volume 2, which is what we want. So clear your calculator. And on your calculator, put open parentheses 720 times 250, close parentheses, divide by 750 kilopascals, and then press the equal sign. You should get 240. And since I've asked you for my volume in milliliters, you are going to give me a volume in milliliters. So pause the video if you need to. Go back over that problem. Make sure you understand what we're doing. And press play when you're ready to continue. Next problem. Given 380 milliliters of gas at 800 psi. Find the volume at standard pressure. Well, let's look at what I'm given. I'm given an initial volume, volume 1. I'm given an initial pressure, or pressure 1, for that's my first condition. And in this, always consider given as your first condition of your gas. Okay? Find the volume, which is V2, at standard pressure, which is P2. Now, we said that you needed to have on hand your list of standard pressures, right? So, if I'm asking for your standard pressure, that means I'm looking for whatever that standard pressure is of the unit that I've given you. And in this case, I've given you the unit of PSI. So if the unit is PSI, then the standard pressure, or P2, is going to be equal to the standard for pounds per square inch, which you should know or should have on you list 14.7 PSI. Okay? So now I have 3 of my variables. I have 380 milliliters for my volume in condition 1. I have 800 psi for my pressure in condition 1. And I have a standard pressure of 14.7 psi for my pressure for condition 2. So we set it up, plug and chug. And once again, here are all of our conditions. We have P1, which is 800 psi. We have V1, which is 380 milliliters. We have P2, which is our standard pressure. And we have V2, which we're trying to solve. Well, we're going to do the same thing we did before. We have to get V2 by itself. So we're going to divide both sides by 14.7. That's going to cancel out where my V2 is, which is what I want, because I want my V2 by itself. And clear your calculator. Open parentheses. 800 times 380, close parentheses. I'm using brackets because they have parentheses on there already. Divided by 14.7. Press the equal sign. Did you get 20,680? I hope so. And since I gave you your volume in milliliters, you give me back my units for milliliters. Pause the video. If you need to, go back over or rewind the video to do that problem to make sure you understand it. Next question. This time I have 380 milliliters of gas at 800 torrs, and I need to find the volume at standard pressure. So my condition 1, V1, is 380 milliliters. P1 is 800 torrs. V2 I need to find, and my standard pressure, or P2, is going to be the standard for 800 torrs. Well, what's the standard for torrs? 760. And actually, some people say Torrs, some people say Tor. I believe it should just be Tor. Okay? So I have all my stuff. I'm going to plug and chug like I did before. 800 Torrs times 380 milliliters is equal to 760 Tor times V2. So here's my P1, V1, P2, which again is my standard of Tor. And I'm solving for V2. I'm going to do the same thing I did before. To get V2 alone, I'm going to divide both sides by 760. So clear your calculator. Open parentheses, 800 times 380, close parentheses, divided by 760, because these cancel out over here, is going to give me my V2. Pressure equals sign. And your answer should be 400. Once again, I gave you milliliters. I want volume. You're going to give me milliliters back. Okay? Next question. 120 milliliters of gas at 8 atmospheres. Find the volume at 6 atmospheres. There it is again. V1, P1, V2, which I got to find, and P2. It's not standard, so they've actually given me P2. So I'm simply going to plug and chug it in to my formula. Here is P1, V1, P2, V2 that I have to find. I'm going to do the same thing I did before. Remember, I said we're only going to multiply and divide. So I'm going to divide both sides by 6 so I can cancel them out on that side and get my V2 alone. Clear your calculator. Open parentheses, 8 times 120, close parentheses, divided by 6. Press your equal sign, and you should get 160 milliliters. I've given you milliliters for volume. I'm asking for volume. You give me milliliters back. Okay. 240 milliliters of gas at 700 kilopascals. This time I need to find the pressure required to make the volume 60 milliliters. My V1 is 240 milliliters. My P1 is 700 kilopascals. My pressure, I do not know. So that's what I'm going to find. But my V2, my volume, in the second condition, I do know. Again, we're going to plug and chug it into the formula. When we do that, we have our 700 kilopascals, which is P1. We have our 240 milliliters, which is V1. This time we do not know what P2 is, but we do know what V2 is. So this time, instead of solving for V2, we are going to solve for P2 by dividing both sides by 60, which cancels it out on this side. Clear your calculator. 700, open parentheses, 700 times 240, close parentheses, divided by 60. Press the equal sign. Our answer for this should be 2,800, and because I gave you your pressure in kilopascals and I'm asking for pressure, you give me kilopascals back. This time it's your turn. So go ahead and do the problem and then check back and see if you got it correct. So given 300 milliliters of gas at 35 psi, find the pressure at 225 milliliters. Go ahead and pause the recording, do the problem, and press play when you T. Okay. So you have 300 milliliters of gas at 35 psi. We need to find the pressure at 225 milliliters. We know that we have P1 of 35 psi. V1 is 300 milliliters. V2 is 225 milliliters. We are solving for P2. We do the plug and chug, where our P1 is 35, 300 is V1, and then of course 225 is V2. We are solving for K. You're going to do the same thing we did before. Divide both sides by 225. Your answer should have been 47 psi if you rounded it. If you didn't get it, maybe it has to do with your setup. Did you remember to take in parentheses 35 times 300 close parentheses and divide that by 225. You have to remember your parentheses, otherwise you're telling your calculator to do something completely different. You can be using exactly the correct numbers, but if your parentheses are not in place where they should be, you're telling your calculator to do something totally different. So just be careful with that. If you got it correct, you're doing just fine. If you didn't get it correct, go back and rewind this video and go through those problems again. See if those questions are now answered now that you're going through it a second time, and if not, please make sure that you address that with your instructor. Okay? All right. Have a great day. Thus ends this lecture.